Hello. Today we're going to talk about different ways to write linear equations. And if you kind of think back to middle school, it's almost like fractions, decimals, and percents, right? Where you have like a fraction, decimal, percent. They're going to look different, but they're representing the same type of information. And that's all this is. So we just need to get familiar with reading the different versions. There's going to be some that are more popular than others, just in terms of like they're used more. Let's just jump in. So we'll start with one that we've seen before, slope-intercept form, which has two parts. So it has a slope, and then it's going to show us a y-intercept. So I'm circling the word intercept, and I'm boxing the word slope, just so you can kind of see the pieces. But this is actually an equation that is in slope-intercept form. So it has a slope, and then it has a y-intercept, right? And if you were to just represent it like in a more generic way, you would just write y equals mx plus or minus b, right? So you could see add a b, or you could have a negative b, either way. So that slope is just the m, and the b, whether it's positive or negative, that's going to be your y-intercept. So in this case, it's negative, right? And the slope is 1/4, right? Which just means it has a rise of 1 and a run of 4. And that b is a -3. And another way to write that would just be as an ordered pair, right? So x and y, the y-intercept is -3. What's really great about this form and why it's the most popular of all the forms is because you can easily graph off of it. So if we know the slope and we know where to start or begin, we can graph a line. So if our begin is -3, right, 0, -3, I can go down 1, 2, 3 and make the first point on my line. And then to graph a line, all I'm going to do is I'm going to take that rise of 1 and the run of 4, and I'm going to move. So I'm going to rise 1, up 1, and then I'm going to count 1, 2, 3, 4, and I'm going to mark it, right? I've done this just a little bit, but I'd like to get more practice with it. So rise 1, run 4. So if I were to connect those 2 points, I'd start to make a line. You kind of see a pattern here, right? If I went up 1 over 4, if I were trying to predict where like the dot was before this one, you could actually work backwards. So instead of rising 1 and running 4 to the right, I could drop 1 and run 4 backwards, right? And if you kind of look at it, right, that space is going to be the same between these 2 points as it is between these 2 points. So the line will be straight when I connect the dots, right? And that's all it is. That's a sketch of the line y equals 1/4 x minus 3. So this is slope-intercept form, right? So we get those 2 pieces of information. Well, probably the second most popular form is going to be something called standard form. And this is an example of standard form. So you have 3 numbers, that 3, that -2, and the 8, okay? The generic form of this is just y equals, excuse me, oops. It's just going to be ax plus or minus by equals c, right? And so you have those 3 pieces. Those will be the 3 numbers you see. The x and y will stay the same. And all you really need to know is that a is always going to be positive, and that a, b, and c will be whole numbers. So you'll never see an equation in standard form where it's 3.5. Like, you'll know that that's not standard form. So the numbers always look really nice. The problem is we can't really graph off of this. So what we would need to do is get that y by itself, kind of like we had over here. So we want to basically take this and change it to slope-intercept form so that we can graph it. So if I want to get y by itself, I'm just going to leave that -2y alone. I'm not going to touch it. Instead, I'm going to try to get rid of that 3x. So it's just a positive 3x, which means I want to take 3x's away. Anything I do to the left, I'm going to do to the right so that the 2 sides of the equation are balanced. Cancel. I'm going to bring down that -2y. equals. And now 8 minus 3x, they're not the same form. I can't do anything with that, so I'm just going to keep the negative 3x. I'm going to write the x first. And then that 8 is just positive, so I'm going to write positive 8. Now I have one more step to get y by itself. So if I have negative 2 times y, I'm just going to divide by negative 2. And then anything I do to one side, I'm going to do to each of the pieces on the right. So divide by negative 2, divide by negative 2. Sorry, that looks ugly. So that's going to cancel. Negative 3 divided by negative 2. Those negatives will cancel out. And I can actually just leave the 3 over 2 because I have rise and a run. And then I have plus 8, negative 2. So positive divided by a negative is going to give me a negative. 8 divided by 2 is 4. So now what's great is I have a slope and I have a y-intercept, which means I can graph, right? So that negative 4, so 0, negative 4, 1, 2, 3, 4 is the first point on my line. And then I'm going to rise 3, run 2. So up 3, over 2. Up 3, over 2. Up 3, over 2. And I just keep the pattern going. The more dots you do, the straighter your line's going to be. Cool. So that's this equation represented in slope-intercept form, which gives us the opportunity to graph it. So, save the worst one for last. This one we'll get lots of practice on. It's actually not that bad. It has two things you need to know. So it does have a slope. So point slope form gives you the slope, but then it also just gives you like a random point, okay? So if you were to look here, that negative 2 is your slope, okay? So the generic form of this would just be y minus, and this will look weird, we'll get used to it. So y minus y with a little 1 equals m, which is our slope, times x minus x1. And those two variables just represent a point. So it could be any point on a line. Instead of like giving you a specific point, like the y-intercept, right? So this gives us the y-intercept and the slope. This equation here is actually just going to give us any other point on the line and the slope. So in this equation, x1, y1 is a point on the line, okay? And so that point on this line is, so let's just actually, we'll mark the slope first. So we know the slope is negative 2, or you could say negative 2 over 1, right? So we have a rise and a run. And then x1, y1. So what is the xy point that they gave us, right? What's weird is you see a subtract here and a subtract here, right? So if I just cover up the y minus and the y minus, it tells us that y1 is 3. So I'm going to mark that first. And then what's weird though is it says minus x1. Well, here it says plus 1. So that negative becomes a positive, which means something's weird about that x1. So really what it is it's a negative 1, and I know that looks weird. You can kind of think like maybe in terms of opposites, like what's the opposite of subtract 3? Positive 3. What's the opposite of add 1? Negative 1. That could help. But the point is, we have a point, we have a slope, which means we can graph. So instead of starting at the y-intercept, we're going to start with the point that it gives us, negative 1, 3. So over 1, and then up 3, right? And then from that point, we're going to rise and run. So rise of negative 2 means we're actually dropping 2, and then we're just going to run 1. So notice I'm moving from left to right always. Drop 1, or excuse me, drop 2, 1, 2, run 1. Drop 2, run 1. Drop 2, run 1. And you'll notice this is the only line that's moving down because it's the only one that has a negative slope. I could use my little trick. So if you see the pattern, right, you can almost work backwards and predict where that line's going to go. So instead of dropping 2, running 1 to the right, I could move up 2, and then move 1 backwards, right? And it still kind of fits that pattern of dots. I got a bunch of dots so I can connect. Ta-da! That's all. So I just want you to have this as a starting point. We're gonna really practice each of these things, but for now I want you to move on. These are the main ones to know. If you can move, if you understand this and you can graph from that, and if you can take an equation like this and turn it into an equation that looks like it's in slope-intercept form, then you are an awesome person. So, good luck with this. We just need notes for now. See you later.